So just to talk about what we are going to try to achieve here is to make a kernel fix generally available. So you have a bug, and you want to make it available for end users, right? And end users are not always building their own kernels, right? So they're using a distribution, or they're using some kind of other downstream kernel. But the purpose here is that we try to do that with an upstream first philosophy, right? And here I try to set up expectations of what's the audience that this is intended for, that I had in mind, and why you would be doing this. Why would you be interested in doing this work? So a hardware vendor maintainer who maintains a device driver who wants to eventually fix the driver bug, they want to fix it for the customers who are using that specific piece of hardware that may be running under different distributions, for example. Or if you are maintaining a managed system that runs the distribution behind it, and you're fixing like a virtual driver bug, a network bug, or a virtualization bug, or a case similar to myself, or a contractor fixing bugs reported by users. And most of the time, that's the job that a lot of people maintaining a distribution do. But if you're maintaining a distribution, you're supposed to know all of these already, right? But maybe you're starting on the job, and that's one of the possibilities here to learn about. So the agenda for the talk, I'm going to do like a quick recap of how the kernel releases work. Then I'm going to talk more about how many different distro kernels may use the kernel, how they end up producing the source code for the kernels that they distribute, and the processes that a fix needs to go through from mainline until they land into the kernel, and which is going to give a view of what's the best way to do it in a way that's scalable. Then I get into best practices for each one of the steps that we need to take, like getting fixes first into mainline, then the stable release, and finally they land into the distributions themselves. So here's a picture of how a kernel release looks like, right? Missing here is Linux Next. Hopefully you can see the pointer here. So let's say we start with 6.5 release. So after 6.5 is released, we have a 2-week window where the development patches are merged into the RC1 6.6 RC1 release. And every week a new release candidate is released, RC2, and usually we have like 7 or 8 release candidates until we get into the release of the next version, which would be like 6.6, and the cycle repeats itself for 6.7, 6.8, and 6.12. The reason I have like 6.6 and 6.12 here at some of the endpoints are because those are what we describe as long-term stable releases. So what happens is that like for 6.6, it gets stabilized and it gets fixes from the newer releases. So a 6.6.1 kernel version is released including fixes that have landed on 6.7. So one of the requirements is that those fixes that are going to land into the stable releases, they need to come from mainline. So you're not going to see here from the point of view of the upstream stable releases any strange patches that come from somewhere else, right? So that's the upstream release process that we should get familiarized with. Just a recap here. Just for curiosity, those dashed lines here, like I picked up real examples just to show that even on 6.693, that gets releases from 6.12 is still getting fixes from 6.12 is still getting fixes from 6.8, for example. So we're still finding out much later in the process that there's a bug that has been fixed for a very long while. And that's one of the things that we could be more careful about whenever we are producing a fix, is trying to document that it fixes a bug so we can identify that, hey, 6.6 is affected. So we should be doing that backport. Should be done earlier, could have been done by 6.6.19, for example, right? But distro kernels, they follow a different process, right? So I have here 4 categories that I thought would be representative of what we have in the field. Some distributions or downstream kernels, they're simply pristine upstream kernels. So you pick up a 6.6.y release and you build it, right? The difference here is that you're not doing a source distribution anymore. You're doing a binary distribution. And so you're using different config options. You may be releasing different versions for the same kernel, same source code. You may be producing a version that's low latency. It has some config option settings for low latency. And the different distributions, they're going to use different compilers, and that may affect the end result. But that's not what we are going to talk about today. So let's leave that aside. So I'm trying to talk more about how the source code is produced. So first option here is using a pristine upstream kernel. Could be still a stable upstream kernel, or even a release candidate. So if you're using a development distro, development version of a distribution, you may be using and running a release candidate version, right? But some of the distributions, they may carry small delta for various reasons. One of them is that they want to include that fix earlier than the upstream table because it's a security issue, for example. That's one of the reasons. Or maybe they're producing a patch that has not been accepted upstream, so that patch does not come from mainline. So before we go into the other 2 categories, just to try to show you one of the examples here, is that a distribution could be simply be distributing from the stable kernel, just picking everything from the stable kernel. But it could also be, as I said, picking up a fix from the mainline kernel earlier than the upstream stable kernel, because they have identified the bug that a user has reported, and the upstream stable has not catch up yet. Or could be that that patch does not follow the policy for the fixes that are allowed into an upstream stable kernel. So distributions in upstream, they have different policies. So it may be the case that it's a fix that does not follow under the upstream stable policy, but it falls under the distribution policy, so they include it. And the other thing here is that they may include like downstream, what we call downstream patches, because they're not coming from upstream. They may, there's a very good example from Debian has been carrying a syscontrol option where you can turn off user namespaces, right? That's one of the things that Debian has been carrying for a while. It's not been accepted upstream, so they kept carrying that as a delta. Debian would be one of the distributions that I would consider fall into this category here. They usually keep track of the upstream table very closely, but they also carry some small patches like the one I described. The other option is that they maintain significant downstream patches for many different reasons, like they have some hardware support that's not upstreamed, or maybe they have like security patches for like a LSM, a Linux security module that they're carrying or that they're patching before the upstream. But they still try to keep up in the scenario here where they still are picking up fixes from the stable kernel. But since they have a significant amount of downstream changes, they cannot simply rebase their changes on top of the new upstream kernel, so they usually do merges or even cherry pick reapply all the upstream patches on top of their kernels. Right? So there are many different methods to do it. But the thing is, they are keeping track of those upstream kernel patches. So they're picking them up. They're not ignoring them and not doing the work by themselves all over again. They are relying on the work that's done here by the upstream stable kernel most of the time. And the fourth option here is that they do many extensive subsystem backports. So they, for example, they may backport the entire USB subsystem, or they may apply a lot of the network subsystem patches. So they may be using like starting with a 5.8 kernel, and then they backport things up to 6.8 from the USB subsystem, up to 6.12 for the network subsystem. And they keep doing that for many different subsystems, and they end up looking like this, right? So that's what those kernels may look like. So here we are. We have like what these distro kernels look like, or they may look like. But what about their processes? Like, if you want to include a fix in a distribution, what do you need to do? The distros, they have policies, right? And some in requirements and processes to include those changes. One of those is that they may require there's a bug reported. You cannot include a change if there's no bug associated with it. So you need to open a bug in their bug tracker in order to be able to include a change. Or if there's no bug number, the alternative is that there's a CV number. Oh, that's gonna make them look at your fix, certainly, right? Sometimes they require that there's a test case or a reproducer for the bug that you're fixing, and they may require a certain number of internal reviews. So you submit the fix, and they need that the distribution engineers are reviewing the fixes and acknowledging that they should be applied. Just non-complete number of things that you must tick in order to get into one distribution, and then you need to repeat that process for every other distribution that you want to support, right? So it's not scalable if you are, for example, a hardware vendor, trying to maintain a driver, trying to make sure that like n number of distributions need to support it. And that's why sometimes some vendors pick up small number of distributions that they want to support, right? But there's an alternative here, because we can bypass all those processes but just going to the upstreams table, because those distributions, they're not putting up the same requirements for the fixes that go into the upstreams table. They do not require reviews, 3 or 2 reviews for each one of the patches that go there. They are not requiring that there's a bug associated with it, or maybe they are, but they do like a single bug, and that bug means updates to upstreams table 6.6.93, right? And you don't need like a test case or reproducer to do that. So if you get your fix into the upstreams table release, chances are very high that you're going to that fix is going to be included into the distro kernel eventually, right? And the fact that the distributions are doing this, it's good because they're showing a good upstream philosophy, upstream first philosophy, a desire to reduce their delta and be as close as upstream as possible, trying to catch up. And it'll, as I said, it allows those fixes that we are trying to distribute to follow through these upstream process and end up in the distributions. So essentially going back here, we are trying to, well, also like here, we are trying to get our fix from the stable kernel into the distro kernel. And in order to do that, we need to get that first into the mainline kernel. And since I brought up CVs, just for a quick note here, it's not always the case that you're going to be able to include your fix in a distribution, because if the distribution version has gone into maintenance mode, extended maintenance mode and things like that, they are going to restrict even more the fixes that they're allowed to change. So most of the cases, they are only some CVEs, only some security issues are applied, security fixes are applied. But just so we know, like since February 2024, now every commit that goes into an upstream release gets a CVE, so you got to pick them all, right? So let's talk a little bit about the process that we need to follow through. First one is the mainline development process, right? So as we are saying, now you want to get the fix. You got into the conclusion that the best way forward is getting the fix into an upstream stable release, but first you need to get that into mainline. So the mainline development process starts with the contributor, whoever's fixing the bug, sending a patch to the maintainer. The maintainer does reviews, and one of the things that might happen, sorry that I have like it kind of written down here as well, so you can understand some of the possibilities that might happen, is that further revisions may be necessary. So you send a patch, the maintainer says, okay, you need to fix this here for cosmetic reasons, or because I think the fix is not appropriate, or it's not maintainable, you should be doing this the other way around. So you need to take into account that not always the maintainer is just going to blindly apply a fix, right? It needs some review process, and you may need to follow up with further revisions. But the maintainer eventually applies it, and in the future, usually that process depends on where we stand on the release process of the Linux kernel, right? If you're in the middle of the merge window, that 2 weeks that follows after release before there's the next RC1 release, that's a very busy time for people to send patches to Linux. So usually that doesn't happen, but after RC1 and maybe after RC2, that's when the maintainers are starting to pick up fixes. And if it's a very important fix, it's probably going to be sent as a pull request for that same cycle. But sometimes the maintainer doesn't consider that as important, or maybe considers maybe a little bit invasive and wants it to wait for one cycle of development. But if it's a bug fix, in most cases, it gets submitted during that development cycle when a maintainer sends a pull request with all the changes on the subsystem, and Linux eventually merges it. Now, you don't need to have it released. So here's the mainline track, right? Let's say you have an RC 6.6, or let's say you have like a 6.12 RC2 release, and your bug fix is applied, and now have a bunch of other things applied on mainline tip, but RC3 has not been released yet. It doesn't matter. If it's fixing a bug, it may be picked up by the stable maintainers. Mostly it's Greg and Sasha doing that work. So that same bug fix, it's cherry-picked into like 6.6.90. Then we have like a 6.6.y query that receives all, there's a tree, a Git tree, that's a query that gets all those patches, until at some point, on a weekly basis, and things like that, the stable maintainer decides, okay, I need to cut off here and start doing a release. Then there's also a release candidate. So they submit all the changes that they intend for that 6.6.91 into a mailing list, into the stable mailing list for testing and review. That's one of the things that I think it's a good time to try to show it up here. How does that work? Okay, so that's usually how it happens. So here you have like a 54295 RC1 review. So it has the list of all the patches, but you also can use Git. You can go to Git. There's a stable query tree where you can fetch it. And then you can build a kernel for testing. And that's what people usually do. Like, for example, Florian here says, okay, on this architecture using 32 and 64-bit ARM kernels, I build tested it with these config. So here's my tested by, right? So a lot of people do these sometimes voluntary work, and sometimes there's some robots, or so here Linaro, for example, is using an ARM dev config, and they found an issue. So now this is gonna be on hold until people decide what to do with this issue. This particular one, like I was looking for, were there any changes on this file, and there weren't. So maybe it's the compiler or config options that are being used here. So we need to test the previous version, verify if the same issues found there, things like that, right? Here again, maybe we have like a node issue that has been there for a while, maybe has been fixed on a later kernel, just not have been picked up for the 5.4 kernel yet. Could be the case. So back here, this is the process that I mentioned, and here's some of the things that you need to do to follow that process. And we'll go into a little extra detail later. But basically, the fixes that they need to land in mainline, may get picked up automatically. So I'm not sure if any of you were at Sasha's presentation talk yesterday. Like he has these auto cell too, where he tries to identify any commits, any fixes that are not present on the stable kernel yet, but that are fixing a real bug that then needed to be backported. But there's also a different mechanism that we can use, we as the contributor that wants to get those fixes into the stable and the distros eventually. In the first place is that we add a cc stable at visual.kernel.org. If we do that, that's automatic signal to the stable maintainers that, hey, this fix should be picked up, right? And that's usually what an automatic thing to do. But even if you don't do that, if you're fixing a bug, you should be using a fixes line too. So the fixes line, they identify the commit that has introduced the bug. And it may be the case that the bug has been in the kernel since forever. And by forever, we mean since the dawn of Git. So since 2.6.12 RC2. Or if it was present before that, you may just use the first ever Git commit in the Linux kernel as your fixes line, right? That's also doable. But otherwise, you would identify which commit to introduce. So that's a very important step that you do in the first place, not when you're doing the backport. It's when you're submitting your fix to mainline that you do those two things here. But if they're done, the maintainers are going to identify that these need to be backported, and they're going to be queued up automatically for you. So I have a good example here as well. So this is a patch I submitted. I'll go through a little bit of the details on that patch later. But the important thing is that eventually Greg just sent me this email. Hey, I picked up this for the 6.5. I picked up the same patch for 6.12, 6.6, 6.1, all the way back to 5.4. Because it was fixing a bug for all those kernels. And eventually when he cut off, now I need to, this is the step when it gets into this query here, right? And then when he cuts off the release and, hey, this is a RC of the next stable release, he sends these emails. It's basically the other thread that I showed you, but the individual patches there have been submitted by the author. The author gets a copy of, hey, I'm applying these to 6.6, right? Okay, and as I showed you, the community may test it and say, hey, we I tested it boots on my system, or I ran these suite of testing, and it works. We didn't find any regressions, and eventually the release is done. People are satisfied with it. Now, distro kernels, as I described, like they have a release 6.6-A. It's the kernel that your user is actually running, right? This is a kernel that the distribution user is running. But how now the distribution gets into 6.6b that your user is going to update to is that these 6.6a, they may be based on 6.690, and the distribution takes not, because the upstreams table, they're almost weekly. So every week you have a new release of the upstreams table. And the distributions, they have like QA processes that they go through, so they usually take longer than that. So they don't usually do weekly releases. Some distributions have the view that users don't want to reboot every week. So they also try not to produce a new update every week either because of that. So they may have to pick changes from both 91 and 92 at the same time to apply. So they apply, they do a merge, for example, and maybe there are new downstream patches, they found bugs that affect only the distribution or bugs that the upstreams table has not caught up with yet, and they want to fix. Maybe it's an important fix for one of their customers or users, so they end up applying new downstream patches as well, which ends up with the 6.6-B source code that they build and test until they're happy with it. If they are happy with the test results, they ship it. If not, they may repeat that process, identify which bugs have been introduced, regressions, try to fix them, and eventually do a release. Basically, that's what's written down here. Right. So let's now get to the best practices. One of the first things that you should do when you're fixing a bug is include information about the bug, like with the stack trace that you have, like any message from the message, pointers to reproducers, a description of the bug, and description of the fix. So here's why I have these example here, so that I have a reproducer right here, right? So if you run this code, of course it needed a lot of other boilerplates to do it properly, but like this is the essential part of the reproducer here, and it happens that it hits this line of where there's a bug on, and here's the stack trace that we are left with, and there's an explanation that this happens because we are using a signed int instead of an unsigned int, and the fix is moving to signed int. In this case, actually it was the other way around because it's 32 bits and we needed like 64 bits actually. The other thing that's good, so here's the fixes line that I mentioned, right? So this commit introduced this bug, and that's how they identified that this needed to be backported all the way back to 5.4, right? So I want to increase this a little bit. Okay. Is it better? Okay. This was actually reported by a syscaller that does fuzz. It's a robot system that does fuzzing of the kernel, and it was found by that. So I did report it by and it closes. It's also important information. And I did the CC table that I mentioned as well. So when you do that in the first place, what ends up happening is that it's pick it up automatically. You don't need to do anything else, like it's going to be applied, right? So add a fixes line, and if possible, try to be as small and self-contained as possible because that is going to make the backports easier. So one of the other things that you should build, test it, check that the patch follows the proper guidelines, one of the tools that we have under the scripts directory is the check patch. Follow the subsystem guidelines. NetDev, it's one that has a specific guideline inside the documentation of the kernel, and send it to the right people. So I have submitted a few ext4 fixes, and they didn't go through very quickly as this one. But since I identified that, copying these, instead of only copying that, so I should copy aid user and Giancara, like they were the ones who quickly reviewed things here, right? So it was, and so it's reviewed by, another reviewed by, and eventually like Tad applied it, right? So that's helpful to get the right people copied in the first place. Now the upstream stable process, everything goes fine. It gets into mainline, gets queued up automatically, but sometimes it doesn't happen, and you need to submit it to the stable because you forgot to do a CC stable, for example, right? You forgot to add the fixes, and the alternative is to go to the stable mailing list and just send a message. There's a pretty good documentation here under the kernel. Right? So if you follow this process here, they describe what you should do. It's just, hey, can you pick commit SHA-1 here for kernels 6.6 and 6.12, please, right? And they're happily going to do it if they look at the commit and say, hey, it's a clear bug fix, right? Because they have requirements, as we were talking. And you can read more about those requirements in the same document here, right? It needs to fix a noops, a hang, that corruption, just basically a copy and paste of that documentation, so can go read there. But doesn't do new features, right? Even trivial fixes, they try to avoid it. Oh, they're just fixing a typo in a comment. They're not going to apply it. They say they don't fix theoretical issues, but that's borderline. Serious performance issues they may fix, right? But sometimes they don't. So basically that's the easy process, right? Sometimes you need to follow a less easy process here, like in this case, they tried to automatically apply it. They tried it, but it didn't work because the commit was not small and self-contained, right? It was longer. So, okay, as you can see here, right? It's a little longer than like just that single line. So they tried to apply it. It didn't work, so they sent that email, and I got that as the author of the bug. So I could work on it, but the maintainer was quicker. He just submitted that. So what you do is that, you need to add like something like this, upstream commit SHA-1 or commit SHA-1 upstream at the beginning. Where is it? So, okay. Here's how like a cherry picked from commits. That's not the usual thing that the upstream does. So here I have a different example. I commit upstream. You need to use this is the mainline commit, right? You need to add your sign-off, your extra sign-off. And in this case, it was not that the backport was not trivial. That's therefore why it wasn't done. It was not done because, as you see, there's no CC stable or fixes line here. So it was not identified as a necessary fix. So I added a comment here. We call this the scissors. So we add the scissors here, these three dashes, and explain why this is important to apply, right? Because it didn't describe kind of as I said, like what's the issue? Right? There's a description of the issue, but it was not sufficient for people to pick it up as like it causes hangs, causes out of memory, things like that. And notice that the subject prefix, this part here of the subject batch, you identify which kernels these need to be applied to, right? So this is one of the things that you do. And if you want to read more about backports, how to do it, how to fix conflicts and things like that, there's a good documentation in the kernel too. And essentially, that's how you get fixes into a distro. You get them into mainline first, and eventually get them in an upstreams table, and the work is done, right? But if not, here's what you need to do, just a quick list of things that you need to follow. You need to open a bug report. You need to read their process. There's probably a documentation describing what you need to go through. Do you need to send it to a mailing list? Do you need to use a GitLab? How you need to format it? Do you need to identify the upstream commit ID, things like that. You need to add some documentation saying, hey, here's the test case, here's how I reproduce it, and here's how I tested it, and ask for their reviews. So essentially, if you want to do it the easy way, I suggest that you do it like this, right? And that's it. Questions? Okay. So,
yeah. I know you talked about fixes.
Okay.
For the impatient people in the room, I'm sorry that
okay.
maybe I'm the only one. What if you have a feature, you're adding kfunc for eBPF, and you want that in distros?
Okay, so the question, so the question is if you're, instead of pushing a fix, you want to push a feature, that's probably going to follow, not follow the upstream policy, so you need to follow the distro policy. So that's what you're going to have to do is follow that documented process. And some distributions are not going to do it, right? So Debian is one of those where they don't do it, like they are keeping track of the stable tree most of the time. But Ubuntu, for example, right, I did some work there. So you need to open a bug and a request and have, hey, this is why I need it. I need it for this application. I need to, and trying to track certain things in the kernel here. That's why I need this kfunc. Here's the patch. If you do it, like you're gonna be thankful for that. It's less work for them. It's easier to get it done. And as I said, like they have a process where they ask you to give like a reproducer. In this case, it's a feature. You must like try to show, hey, run this program here, run this eBPF program here, for example. And here's why I don't think it's going to regress the kernel. That's very important for them. So that's one of the things that they require. At Red Hat, I remember they had a lot of test suites. So you needed to add like a new test case when you were fixing a bug. For a feature like this, I'm not really sure what the requirements would be. But yeah, the problem is that it doesn't scale, right? That's sad, but but it's a feature. For bug fixes, it's much easier to do, right? Any other questions? No. So we're out of time. Thank you, and if you want to talk, I'll be at the booth at Igalia B12. Thank you very much.